Alright, so today we'll be talking about areas of trapezoids, rhombi, and kites. Okay, now a trapezoid typically looks like this right here. Only one pair of opposite parallel sides. Pretty simple. Okay, now the actual formula for how this actually arrives is you take the midpoint, the mid segment, okay, and what you do is you lop off this entire top part. So we're going to pretend like we just cut this off, and we're going to draw it off on the side, and we're actually going to flip it over. Let me use this. We're going to flip it over this way. Okay, so we've cut off the entire top part. Well, guess what you've made? You have made a wonderful parallelogram. Okay, so that's some really cool stuff about it. Now, the formula is not as easily explained as that. Okay, but if we go about it, okay, let's write it out. So the formula for the area of a trapezoid, and this both is isosceles and regular trapezoids, is 1/2 times height times base sub 1 plus base sub 2. Okay? So now a lot of people are probably sitting there going, I don't get where that formula came from. If you think about it this way, it actually does make sense. Okay? Height is listed just like what we've been talking about before as this. Okay, so this is height. Now if we've cut it in half, we are now dealing with half a height. Okay, so this is half, so this is 0.5. So this is 0.5 height. Okay, so that kind of explains the sense of why that is there. Alright, now, the other part is that if this is base 1 here, so this is base 1, and then this is base 2 up here, okay, now I've moved it down to here, so base 2 is down here, okay. Well, if you think about it, parallelogram is just kind of like a little bit of a shifted rectangle. So now I have my total base, which is base 1 plus base 2, times half of height. Oh, and I just realized I wrote just 0.5 height. So let's move this over a little bit. 0.5 height. There we go. That should be a lot better. Okay, and so this is my height, my new height, and this is my new base, and so that's just base times height. Okay, that's the really cool thing about trapezoids. Do you need to prove this right here, this actual reason as to why the trapezoidal area rule is this way? No, you don't need to, but you do need to understand is that you need both bases and the height and then times it by half, because you're not using whole height, you're using half of it for the actual length of, or the height of the trapezoid that we're working on. Okay, all right. The other shapes that we'll be dealing with are rhombi, and if you remember rhombi are parallelograms where all sides are congruent. Okay, so that's pretty simple. Okay, and then kites. Okay, now kites are going to be hugely important, not just because of their cool shape, but because their formula actually explains how to get a rhombus. In actuality, it explains how to get a rhombus area if you're just given the diagonals. Okay, now the kite is going to be consecutive sides are congruent. Two pairs of consecutive sides are congruent, no more than that. And this one technically could be the same thing. So you could say a rhombus is actually a kite with all sides that are actually the same length. Okay, but here's the cool thing is that you can actually use their diagonals to get formulas. So the area for the kite is going to be area equals 1/2 times diagonal 1 times diagonal 2, and that's for both of these. So this, when we're talking about the diagonal, we're talking about the whole length, not just this part that I'm marking out. Okay, so diagonal 1 could be that, or it could be this, and this, You know, there might be some detective work that you need to actually find the diagonal or the length of the total diagonal right here just to work with it. Okay, but if you are just given the diagonals of a rhombus or a kite, you can actually find the area using this. Now the area up here, since this is a parallelogram, is just going to be base times height if you are given base and height. But if you are not, and you are given the length of the diagonals, you can actually just use this formula right here. Okay, so as we work with it. Now, sometimes they may give you the area and they might not give you one of the length of the diagonals. So just plug in the numbers as is and then solve for the new number. So that's the beautiful thing about area formulas, is that you can actually work with them pretty easily to find other missing variables other than area. Now, you also have to remember some rules too, is that when you're dealing with rhombi and kites, that they intersect at a right angle. Their diagonals do. Okay, so when the diagonals intersect at the right angle, what we are making is not parallelograms, but right triangles. So you need to understand is that you might need to be able to find out what one of the sides of a right triangle is. Okay, just based upon some of the information. So if you're given D1 and then this side right here, you may need to use Pythagorean theorem to actually find the missing diagonal side. Now another cool property is that in kites, these two are going to be congruent. So if you know one of them, you know the other measurement, so you can get the total length of diagonal 2. Okay, and then on this one, these two are going to be congruent as well as these two. Okay, right, and so there's all the little tricks and know-hows and knowledge and missteps that you're going to need to know for trapezoids, rhombis, and kites. Okay, that's it for area. I'll talk to you later.